Morning, everybody. Can you hear me in the back? Okay, all right. Yeah, I've got teenage kids, so I can yell. Good morning. Welcome to Roll Your Own Internet of Things search engine. I'm Keith Perry. I can't come up with really cool names like Samurai WTF or Backtrack. So you're stuck with me coming up with things that don't make good acronyms. So the slide I'm going to read verbatim, because my lawyer won't support me on any of this, or cross-country car races, come to find out. Disclaimer, the information, opinions, views, and advice are strictly mine and not of employers present, past, or future. Hopefully my current employer will not think that I need future employment. Use of any code, provider, or techniques described at your own risk. When you see my code, you'll understand why. I'm not a lawyer. Your mileage may vary. Past performance is not an indicator of future performance. And your cloud provider may not interpret the terms of service like I did. Come to find out, they don't. So, with that said, my background, doing IT for about 20 some odd years or more. We'll go with the more. Currently, I'm the pointy hair boss for a large insurance company of pointy hair bosses. So I'm in somewhat of security, do integration, middleware, infrastructure. I'm the guy they call in the middle of the night and ask why things are broken, and then I stand over people's shoulder and ask when it's going to be fixed. And there is one person in this room that has been subjected to that. But he didn't work for me, thank God, Kevin. Passion for new technology, security, got some education, didn't help any. Early geek, licensed in amateur radio, loved electronics as a kid. Would have been an electrical engineer, but University of Florida didn't really partake to my kind of people. Why a search engine? So I've spent most of my life on a conference call. If you ask my kids what I do, they tell them I do conference calls for a living. Back on a conference call in probably 2000 or so, I started typing in IP addresses because I was not overly concerned about whatever it was that was going on a conference call. I started finding some really cool devices and went, hey, if I wrote a script to do this, I could stay completely entertained during conference calls. You'll get to see that 15 years later. So I thought, well, hey, everybody's doing this thing where they're making money. I'll turn this into a site that'll get a lot of hits. So I went out and got a domain name called randomlook.net, which I think I still own. Come to find out, there's a guy who has a patent on displaying random images on the web. I haven't talked to him, but I thought, for the $3,700 I'll make over 10 years, the $3.7 million investment I'll have in law fees will not cover it. So it's still blank, I think. Platform to explore different technologies. What I do, I enjoy, and I enjoy doing it off, with my own time. Kind of a Lewis and Clark syndrome thing. I enjoy seeing what's around the next corner, which is really cool for certain things. If you go ride mountain bike me or whatever, you may get lost. This was pre-Shodan HQ. The next slide will cover. How many people know what Shodan is? All right, very good. You're my kind of people. Project to learn about cloud computing. So I had some stuff going on in my work side of life that I needed to learn more about cloud computing. I thought, hey, this is really cool. But Shodan search engine. So you're all thinking, well, that thing's great. It is. Shodan is great. This won't replace it. This was me having fun over the years before Shodan got started. There were some things Shodan didn't have that I thought would be really cool. Some of them I know why Shodan doesn't have now. Thumbnail screen capture, search on HTML, browse data, unlimited search queries. Now there's one that I do have that I like, and that's private queries, that no matter what goes on, nobody gets to see my queries if it's running on my box. So the bad news is, to get that, you pretty much have let the entire internet know what you're doing. I took two different approaches, so we'll talk about the first one first, the second one towards the end. Hopefully I won't run out of slides. I've either got way too many slides or not enough slides, one of the two. Two approaches. Build from scratch, which is what this really kind of started out. LAMP stack, Linux, MySQL, Perl, PHP, whatever you want to call it. ZMap, Nmap, Perl. I used a Bitnami Ubuntu for a prepackaged image. I used the Amazon cloud. There's some debate whether or not I should put up actually what cloud provider I was using, but at this point I'm sure most of the internet knows. Sonar project scans, if you're not familiar with them, we'll get to those in a minute, but scans.io, which is the Sonar project, some full internet-wide scans of ports that they've made available, comes into play here. WK HTML to image. And the second approach was a cloud search service using the Amazon Cloud Search. The Sonar project scans in Perl. So, and if you have questions, let me know. Probably don't have answers, but I'll be more glad to acknowledge you. Collecting data. Two different types of way I went about collecting data. Nmap and Zmap scans to collect valid IP addresses. And then I wrote some code to actually go hit those to pull in the data that I was looking for. Nmap, everybody's familiar with Nmap, I'm sure. Nmap is slow and targeted. Zmap, I don't know, anybody use Zmap in here? Okay. Zmap is incredibly lightning fast. It's a shotgun approach, and if you run it, people will like tell you have run it. Come to find out. Sonar project files I talked a little bit about a minute ago. They are full-size, full internet scans of ports that they have put together and dumped the data down. Very, very interesting. You can parse those directly into a database, is part of what I did. They're very large. The port 80, uncompressed is 250 gig. It's 65 gig compressed. So there's a lesson learned slide in here, and I'll talk about some of those, but those are some of the hurdles you have. Start trying to pull down a 65 gig file, and people in your house will start complaining that they can't get to Netflix or etc. And by the way, Netflix not working at my house is a sub 1. So various ports available, and it's point in time. They do a new scan about every 30 days. So I tried to set this up so that the database schema would handle multiple ports and protocols. I really focused around HTTP. It's got some FTP and SMB in there. The ethical thing and trying to stay on the right side of people who could complain. I played mainly with HTTP. The concepts, some of the code, etc., are expandable, and you can use for whatever port you would like. The parsing of the Sonar files, I tried to write code that would pick up and run most of their stuff. I can't say I tested on a lot of them, but on a couple different files. The setup files that I'm going to talk about, so you could go do this and play with this at your own risk, is at this SourceForge.net project. It's ROYOSET, and it is indexed. And right after I built it, I couldn't find it, so it was indexed on their search engine. So approach one, talked a little bit about this early on. Approach one was to build a LAMP server, and then configure MySQL, copy some files to HTTP docs for Apache, and create so I'll walk through this a little bit. So the first thing you need, I started with a LAMP server. I started with an Ubuntu version. That's kind of what I'm familiar with. I used Bitnami, which is a provider of images. They build them for whether you want to run them on your local desktop or a cloud image. They have both, so it works well. When you create that, if you're going to do a full-scale port 80, you need to add about 500 gigs of disk space. That's not too much. Configure the MySQL database is the next step in that. And let me just back up. All of this was built without security as a concern for my security. I built this stuff and brought it up and down at my will, made backup copies, and if someone hacked it and it got blown away, it was no big deal. So if you go and do this, realize I didn't go into a whole much trouble. I was using the default MySQL password and user ID for a while. So anyway, configure MySQL database. You need to add a little bit of security there so the scripts that I have written will run. You need to copy the PHP files, which are the front end of the search engine, over to that. As you can tell by how creative my slide design is, my PHP files that run for the front end are just about that creative. So I'm not a graphics, I'm a back-end database kind of guy, so bear that in mind. Create a directory called scanner to put scripts in, and copy all the other files in there. So, and there'll be a README up on that SourceForge.net site that will provide a little bit more information about exactly how to go into this. And I'm not real sure when we started and when we're stopping, so I'm going to try to run through this pretty quickly. You need to install ZMap, install Nmap, install WK HTML to image, which is a screen capture program to then create images off of it. Very cool tool. I had a lot of difficulty making it work for what I wanted to do and the quantity that I wanted to do, but we'll get to that later. Install Perl modules until things work. I used a ton of different Perl modules. I can't tell you all of them, and every time that I tried to come up with a list of all of them that I needed, I kept, finding more. So.
Isn't that how every admin runs?
Huh?
Isn't that how every admin runs?
Pretty much. So Kevin and I have a small history. We have worked together in the past, and worked was a relative term. Set file permissions, firewalls, and all the other stuff I've forgotten. Hopefully we'll add that into there. So, all right. So once you've got up a MySQL, a Ubuntu LAMP stack, you've got the scripts installed. You need to get some data into the database. So there's three basic stages of this. You need to get data, you need to put it in a database and store it, and then you need to expose it to a front end of some kind. So I wrote a short script to run Nmap scan, which runs some other Perl modules behind it to grab files. And you're going to ask why I used Perl. It was something I was a little bit familiar with, and there were some cool things written in Perl that would parse Nmap files and etc. So run in this script and it'll pull data in. You'll have to go change settings and etc. to do what you want to do. I've got it set up for this just to run pull 1,000 random port 80s. ZMap, same kind of thing. You need to adjust the variables and etc. All right. So that's two different ways of getting data into the database. The third way is to gather data from the Sonar project. And I have to say thank you to those guys. I think it's Rapid7 and HD Moore, I believe. Those guys have done an incredible thing. If you haven't looked at the files, you should. It's very cool. They're out there. That's the HTTP address. Very cool stuff. There's some tricks to parsing it, but I've written some basic files to help you along, and then you'll have to kind of modify it from there. Grab the file. So the port 80 file is a 65 gig file, and it unzips to give or take 250 gig. So you can spend some time letting this run. I know that the first couple times I ran it, I gave it 100 gig, 200 gig. I get up the next morning and it wouldn't be, it would have run out of space. So pull it down, start unzipping it, let it go. Adult beverages, if you're of age, I think about part of the crowd is. And then create a smaller file from that 250 gig to test with and import. To import the database, I wrote a short Perl script that is called sonar.pl. It includes some things in that. It parses that file and puts it into the database. There's also some options in there to go out and do things like DNS lookups for each one of the IP addresses, and also to look up geolocation stuff. Those two things call outside services. They are very slow. So you may want to turn them off. There's an option to turn those off and let it just run. You don't get quite the quantity of data that you want, but it runs a lot faster. Any questions so far? We good? Okay. I gave this presentation to my Labrador, and he had the same response. So. All right. So this is what it looks like once it's run. If you did all of that correctly and you got some data in it and it actually works, you get a very simple, straightforward screen. And then back, I'm sure you can't read it. So screenshot, IP, port, code, response code, and server, and off to the right's title, so it kind of runs off the screen. That gives you a base place to start doing some very simple searches. Okay. One of the things that I wanted that Shodan didn't have was, I was like, that's cool. It's a Rabbit server. What is that? I have no earthly idea. Well, come to find out, Rabbit servers can be a lot of things. Same with, take an instance, it's say an Apache. You can have a lot of things running on Apache. You can have websites, you can have a lot of other stuff running on Apache. So I wanted to add screenshots. So consider this experimental because I never got it to work to what I wanted it to be. There's a couple reasons. There's a script, image.pl, that will run. It will pull in images. It is incredibly, painstakingly slow, and it uses an incredible amount of resources. And we'll get into that some here in a minute. You can change the SQL query, run it. It's multi-threaded, it's slow, and it's error-prone. Pulling back screenshots, there's all kinds of things. So one of the things that I found out playing with this is you're searching the entire world. Well, if you're sitting in the state of Florida, you don't really worry about, how many different languages there are and all the different ways that somebody can code HTML. But when you start trying to parse it, you start finding some really interesting things. You start finding that there are character sets out there that don't parse well. People have put weird things into HTML tags where you would not ever expect them. I'm not real good at regular expressions anyway, but it was challenging to try to make them work. But when you do screenshots, you start running up against things that have a Java or a Java display or an ActiveX display, or just in general they don't respond or they're slow. All those things really come into play when you're pulling the data when it's textual, but when it's trying to grab a screenshot, it really gets very difficult. It does work, but it's very error prone. The success rate is not real good. So, as you can see, I ran and added in some screenshots. I tried to, and just as a general, back to Kevin's ethics talk, I really kind of tried to stay away from anything that comes back and says starts with a 4 response code. I kind of stay away from. If you give out a 401 or a 403, I kind of feel like, hey, you know what? I'm not going to go poke at that. At least I'm not going to make a presentation of me poking at that. So I try to stick with things that are, that have 200s. Those are the things that you typically see some of the more interesting stuff with. So if you look, I did a search for rabbit and server. Okay, and it came back with some various things. But you'll see the screenshots are different between the ones that came back with. You also see they have different titles. So you'll run into all kinds of weird, strange things out there. So this is the part where you might be entertained, I hope. If not, I've failed completely. All right, so one of those, if you go back, there's this black one here, okay? And you could scale these to be whatever size you want to be. I grabbed them in 5K images because when you start adding up, hundreds and thousands and, well, millions of rows, 5K adds up pretty quickly. Bigger than that adds up a lot faster. So anyway, so that black one, come to find out, is a highway traffic monitor somewhere. I don't know exactly where, and I'd rather not find out. But so that's one use of a Rabbit. Well, okay, so what is Rabbit? Rabbit's a server. It's an embedded server. You can go buy the little module and put it in stuff, and you'll find that lots of people have. It also runs in weather stations somewhere, and that one might be easier to find than the traffic one. These are just samples. It's not like this database I was pulling from has 11 million rows in it. Give or take, there's about 300 or 400, somewhere between 300 and 400 million rows in a port 80 scan from a sonar project. So there's plenty out there. This is just one of many. So I really enjoy exploring the stuff and trying to figure out what's out there. Shodan is incredible, but when you sit down at it, you kind of need to know what you're going to search for. They have people who put really cool searches out there, and that helps. But if you're sitting at a screen trying to entertain yourself, coming up with something to search for is not always the easiest thing to do. So I said, I want to write a short little screen, server.php, to go out and pull all the distinct types of servers that I have found. So, and this was a much smaller database. This one only had like 300,000 rows in it. So what you find very quickly is, yeah, Apache is very popular, Microsoft is very popular. You start looking down the list. Okay, so you get down to the ones that are like ones or twosies. And someone has said, I read that thing about security and I should change my banner to be, something cute. Those are amusing. Go up to the ones where you start seeing 10 or 20 out of, 30,000 or 300,000, or you find, a couple out of, a couple dozen out of a million. Those are the ones that are, devices that are often you can find out there that are interesting. Rabbit's one of those. That's one. There's some other ones. BOA is one that's used heavily for webcams. There's one called W3MFC, which I believe it's W3, www. And MFC is Microsoft, the Microsoft framework, MFC from Microsoft, which was popular back, I don't know, late 90s, early 2000s. Somebody probably in here has written in that. Those are out there, and those run a bunch of webcams. But those are very specific set of people using those in webcam design. So you can start identifying webcams that are out there, and you can identify the kind of webcam it is just from the server, much less the title, which also is interesting. So grab some of those and say, okay, you know what? I'm going to go look at some of these different server types. So in that case, I said, okay, you know what? Let me look for embed. I'm just going to look for embed, the server type embed. The query have I set up is a like. If most people, SQL fans, anybody SQL? Okay, all right. So if you use like, you get back a bunch of different things that are very similar to that. In this case, I found, okay, I'll look for embed. I found iGuard embedded. Well, that looks like an interesting server type to go, pull. I pulled it up. There were several hundred of those. I started poking around and saying, which ones of these are, 200s that I won't offend anybody if I go look at their website. This one's out of China. This one is, it says iGuard security system. It's interesting. It's time card, punch in, punch out. And if you want to know, Yin Li was the last guy in or last guy out, and you can go find out who's late in whatever company this is in China somewhere. Interesting things you can find and poke around at and see. So controller. So just go type in the name controller into the search for the server. This is strictly around servers. There's other things you can look for titles and etc. Controller led me to find a bunch of different controllers. Gateway controllers, EFA controller, Aqua controller. Okay? And I was curious, like, how many Aqua controllers are out there and what is it? How many goldfish need to Twitter? Well, come to find out, a lot. The Aqua controller is actually some kind of control module that runs fish tanks. And there's a bunch of them out there. I'll let you explore at your own risk because those all came back with 401s. They appear to be secured out of the box, and I thought, well, hey, cool, the fish are safe. So, all right. This is an interesting one, and I'm going to gloss over this slide a little bit because I'd rather not talk to anyone's attorneys. So an IPG 7000. If you type in IPG, and this is where the server came in, I found IPG 8000 was a server type. And I thought, hey, cool. I went out to those, and they were, they showed an interesting side panel like this. But login screen, and they, all were protected. And I said, that's cool. That's good. And I started looking and realized there was an older version, IPG 7000, which isn't quite as secure as the IPG 8000, it appears. Now, these devices are network communication devices, and they show up typically in, well, a lot of convenience stores out of things that you might get money out of. So anyway, if you notice with those, some of the log files may or may not be available to the general public. I would want to secure them if they were mine. Anyway, the obligatory printer slide. Everybody has seen Shodan, or somebody go, hey, have you seen all the printers that are out there on Shodan? Yeah, there's a lot. There are probably multi-million sitting out there that you can get to the web interface on. Very cool. Use them as they are. You can poke around at them. Back to the whole I can't come up with good names thing. Super Goose 2, which someone earlier pointed out, they use I think it's either a dog or a cow for their logo. Don't know. Not sure how you go with Super Goose 2 and get a cow. Whatever. This is one of those that I found off also doing an embedded server. This completely different type of embedded server. This one provides data back from heating and cooling, and also provides a video feed. And this one happens to be in a laundromat somewhere, and you can tell exactly what the temperature behind the 50-pound dryers is if you scroll down. You can also see who's in there at the same time they're using the 50-pound dryers. What you will find is that there are a ton of mechanical room type things attached to the internet that you may or may not know are there. A lot of them, people up here don't care if they're exposed or not. Some of them, I think they might care. I think every laundromat in the world has a set of webcams that isn't secured. It gets pretty boring after a while. So we watch Jeopardy every night, so I couldn't help but use a Jeopardy reference. So Alex, we'll take Sunny Sun or Sunny Solar for 500. Doing a search for solar in just server brings up a whole set of solar controllers. Now this one was interesting because it's also out in the country, which makes me feel better about showing it on the slide. But it showed their consumption of power, their collection of power, and how they were using it, and historically, current time and historically. But that's not what I thought was really cool. I thought the fact that you could type in Sunny and come back with the Sunny web server. I don't think I have a slide of that, no. Sunny web server, I was expecting a handful. Out of 11 million records, I figured there were probably, a handful of solar panel control boxes. Out of 11 million records, I don't know exactly how many were these, not these, but the Sunny web boxes that were protected, but more than 1,000. So there are more solar panels out there than I ever imagined, and there are more of them connected to the internet than I ever imagined. So those were the interesting slides. We'll get back to what it takes to make this work and et cetera. Lessons learned. So the first thing I learned was that images are very slow and difficult to process. Could be why Shodan doesn't have them, and why you don't see them in a whole lot of other places. Outside calls, pulling DNS information, which one of the scripts that the grab.pl pulls geolocation, it also is slow. DNS is another thing, is slow. And we'll talk about feeds and speeds here in a minute of what you can expect when you're doing this. Storage time for processing full internet scans. Back to that 250 gig. 250 gig is an incredible amount of data for an enterprise to play with, even though terabytes and terabytes of data. But 250 gig starts getting to be a pretty big file size to start messing with. You've got to have the disk space. It takes a lot of CPU to run through it. No matter what, even if you parse out just small amounts, it makes a pretty big database file fairly quickly. I was amazed at how many different things are connected. It's kept me entertained for many years. If I had been smart enough years and years ago to go, hey, maybe people would pay for this data, as someone pointed out, maybe I would have beat Shodan to the punch, but he has done a phenomenal job, and I use it and I am entertained by it regularly. Parsing issues. Back to, you're pulling 300 million or so different IPs, and in different languages with different formatting. And when you start parsing HTML, my code's horrible, and it has horrible format. I've seen HTML that is right on par with my formatting. Different ways to do titles, characters I never imagined anyone ever would put in a web document. There's a lot of cleanup that takes to get data to go from parsing into a database. There's some regexes I've built that just clean things up, and they clean them up to a point where I pulled out everything that wasn't an alphanumeric character, because you just couldn't parse out everything. Some of the multi-bit character sets, whether it's Chinese or Japanese or Taiwanese, very difficult to try to do. Size matters. 1 million or 100 million is a big difference in the number of records when you start stumping them into a MySQL box. And I think the next slide, I'll talk a little bit about that. ZMAP scans are not Ninja-like. You start running a ZMAP scan and people will let you know. So bear that in mind. Anybody who wants to run home and run one, do it off your neighbor's Wi-Fi. But you will get notices from your cloud provider saying, hey, we noticed you were busy. Okay, so speeds and feeds. So I don't know if everybody's familiar with this or not, but Amazon provides you with a free account if you want one. Type in a credit card. It's aws.amazon.com/free. They'll give you a free micro-sized Linux server for a year, enough hours to run it, etc. They will not give you enough disk space, by the way. It's a good start. So if using that micro-sized Linux server, a Bitnami, Ubuntu image, running some of the things, it'll parse about 3.5 million sonar records in an hour. So that's taking a sonar file and parsing it into the database. About 3.5 million per hour. So if you run the numbers, it takes about 100 hours of processing time to run that 250 gig file into a micro instance. That's assuming that it doesn't fail somewhere in the middle. Very difficult to parse a single file multi-threaded. I've got a computer science degree, but I've barely got one. So that's way outside of my league. Some of the other stuff you can do multi-threaded. Pulling IP data from IPs and etc. Yeah, you can do multi-threaded. The grab.pl that I wrote is multi-threaded. Would run about 50. Matter of fact, following here. Grab.pl, I would run about 50 threads on a micro instance, which is a very, very small instance on the Amazon cloud infrastructure. 50 threads, approximately 10,000 IPs per hour is how much I could process, give or take. You run out of CPU very quickly. You don't run out of bandwidth, you run out of CPU. And that's even setting it so that the threads disconnect pretty quickly out to connections. ZMap, you can run about 10 million IPs in about 45 minutes off of an Amazon micro instance. That will not go unnoticed. Let me tell you right now. They will notice. You will get emails from people going, hey, screen captures, brutally slow. There just isn't enough resources there with a micro instance to do that. So when you start moving up the chain and start running to an 8 CPU box on a cloud infrastructure, you can do a lot more pretty quickly. But yeah, there is a charge. I've got 2 one-use servers sitting underneath my desk at home that I used to use for this, but I found that the bandwidth was the concern then, not necessarily CPU. It was bandwidth. I couldn't consume all the CPU I had because I didn't have enough bandwidth on a DSL type connection. So shifting gears a little bit, I said, this was cool. I want to play with some other things that I haven't tried lately. So Amazon has a beta feature out called Cloud Search, which is basically a search engine in a box. They give you a search engine in a box. It's actually pretty cool. It's not just cool for this, but it's cool for other things. And I think they actually have a free program to try using that too if you want to play with it. So Cloud Search, basically you're going to take data that you have and dump into that somehow. They really like JSON and XML, I think, for a data feed into that. Luckily, the data files from Sonar are JSON. Bad news is there's a whole bunch of base64 encoding in those Sonar files that you have to unencode. So I wrote a script to do some of that called sonar2cs.pl, which was really kind of where I was just dumping it in the database before, but instead of dumping it in the database, I wrote it out to a CSV, a comma separated file. You need to run a basic file and get a handful of records to start with before you start building your Cloud Search instance. Save that file and use that to basically build your index, what the indexes will look like when you use their facilities. And you're going to upload that file during the creation, which we'll get to in a second. So, how are we doing on time? Left?
Like 10:15.
Okay. All right. So I'm going to run through these pretty quickly, but this was really simple to do. It only took me about 5 hours to figure out how simple it was. The documentation is a little sketchy. They call it beta for a reason, I'm pretty sure. Throw in a domain name. You leave the desired instance type and replication count as a default, and it will scale up and down as you do your thing against it. You're going to browse and find that Sonar file that you just built and upload it. So that file has a handful of things in it. It's got maybe 10 IPs in it, is what you want. It then will take and figure out, when you pulled it in, it'll take and figure out what the actual fields are in that file that it's going to index. You need to modify it a little bit. This is where it took me a few hours to figure out why my searches never worked. You have to change the type to a text. It comes up with a literal, it doesn't work. One of those things that I don't know is really described in their documentation. So once you've done that, you're then basically going to kick it off and it will start building the indexes. It is a little bit slow. Even with no data in it, building the indexes took quite a while. It probably took 15 or 20 minutes for it to build indexes on 5 records. I don't know what it's doing in the background, but that seemed like it took a little too long for what I was expecting. Matter of fact, figured I had done something wrong several times until I finally just waited it out. All right, so once it has indexed and it tells you it's ready to upload documents, you can grab a file and run as many records as you want with a couple limitations and then upload them. So that'll put your data into their search engine. All right, so once you've done that, you can run some test queries from their actual control panel. What it'll do is give you back what you were searching for. You know, their search engine is, you know, much more robust when it comes to ands, ors, different types of things you want to return, etc. It returns back this screen, and it returns back some raw data that you can see what you're getting back. If you do it from a web browser and you have to set up the access to get to the cloud search, there's it's almost like a firewall type panel to let who and what IPs you will allow to get to this search engine, to upload documents and also to do queries. So you can control that. When you set that, this is another one of those things. Once you have set that, it takes quite a while for it to actually take effect where you can actually hit it. So you get like a 401 or a 403 for quite a while, and you try to figure out why your query isn't working. Come to find out, you just have to wait for them to finally process the rules. Once you've done that, you can send in a query, and they give you the format. And as you can see, I was basically the IP address or the domain name with search $Q equal Google, and that came back with these fields. I think that this could be used for certain things. For what I was looking for to play with, it really didn't give me what I wanted. I kind of enjoyed having the entire database at my disposal. But if you're building a product, that you know, whether it's a security product or it's going to run locally, or a website that you've built that's going to need to pull data from a search engine that has pretty good capability, this has got promise. It's easy to build, availability, scaling, access is provided. You know, so all those things are taken care of. You don't have to go figure out how to make a Ubuntu instance work. There are some limits. It's limited to 500 gig, so you know you can only have one database, but you can build multiple databases. So if you were going to index all the port 80 and all the port 8080, you probably would exceed what this has for capability. The upload is one of those things that is a little limiting for this, because they want you to upload documents that are less than a meg, and in batches that are 5 megs or less. So to upload, give or take, you know, 300 gig takes a bunch of different files and a bunch of different batches. So it's kind of hard to do what I wanted to do with. You could write a script to parse them out and do it, but it just kind of seemed like a lot of effort. Like I said, a possible fit for tools later on if you were building something. Some potential technologies and features that I bumped across that I thought would be cool, maybe get to play with later. I'm out of time to play with this for right now. It's one of those things in your life, you have lots of time, you sign yourself up for the BSides and say, I'm going to go present, and then you get a new job position. I get promoted, which was great, except for I had no time to work on this. So it is what it is. I would love to run MongoDB versus MySQL. With the Sonar files being in JSON format, they should import pretty easily. There's some base 64 decoding that has to happen. You notice I didn't say you had to decrypt it. So anyway, that would be cool to see what the difference is there. I think the performance for MongoDB would probably be substantial over what you get out of MySQL. When you're running MySQL searches on millions and millions of records, it takes a lot of CPU. The micro instance, once you get over 20 million records, isn't going to cut it unless you're willing to sit a long time and wait for your searches to come back. Question, would Solar search engine, which is a open source search engine, how would that work compared to like cloud search? Wasn't as easy to set up. At some point, maybe I'll get around to doing that. Cutty Captain versus WK HTML to image. You know, would that be a better image capture program to do what I was doing? I don't know. ZBAP also provides a capability where you can build a banner grab, and I believe that's what the Sonar project has used, and they made it work. I never could get it to work, but I'm not a Unix guru or Linux guru, and you know, so getting that to work would be a step in the right direction. One of the things that I wanted to do, never got around to, was I wanted to be able to take and grab images from a whole bunch of different websites, run an MD5 on them, put them into a database, and then say, oh, yeah, all of these are equal, even though the server names are different, or etc. I haven't gotten around to that. Maybe one day. The other one is to classify records. You know, yes, there's a bunch of different Rabbit servers, and if you can pull enough data back, you should be able to classify what they are and what they're being used for, which kind of takes, you know, some of the exploring fun out of it, but it would be a time saver. And that might actually have some real practical use. And improved search engine front end. So, all right, so all the files are there. There'll be a better README up in the near future as to actually how to set this up, etc. And then questions and heckling, because I expected heckling from certain people, but it didn't happen, so I was kind of disappointed. Any questions? All right, I never like to be between people and lunch, so thank you guys.